So now we are starting on the collections. What do you mean by collections? So till now we have seen about different kinds of data types, right? If I say about like what are the basic data types? Int, float. So there is no long in Python 3. So float. And we have string. So none, or like boolean, which is true or false. So these are all the basic data types. But in reality, do you have like only one value? We will not have one value, right? We will have a set of values or a group of values. That's the best way to say. Just imagine like if you have rice, if you want to carry the rice, if it is small quantity, you will take in a bowl. If it is large quantity, you will take in a bag. Just take the example of a sand. If you want to take a small sand, you will take with a hand itself. If you want to make more, so you will take a lorry or like you will hire a bigger truck. Let's take the example of water. If you want to drink, you will take a small glass of water. But if you want for washing or something, you will take a bucket of water. But the same water, if you want for a purpose of an agriculture or something, you will bring like, so a better pipeline, right? So means we have the basic data, then how we are calculating, so moving that. So that is the point of data structure. So basic data types, these are like, so data types, basic. And then comes like data structures. Data structure means the data will be stored in a particular structure. Means based on the structure, it has its own rules. From a water tanker, is it suitable for like drinking? Not like with a glass, right? So we need to do in a different way. But it is for drinking water only. In the same fashion, so data structures are of different types. In reality, so Python starts with like 4 data structures, which is like a list, tuples, and sets, and dictionaries. So these were the 4 data structures Python is supporting. But in reality, are these the only data structures? No. There can be n number of data structures. You create your own thing like that. You might have heard about queues, stacks. These are all data structures only. By the language itself, they came with these kind of data structures. Sir, what if I want to create the new data structures? For any custom object, if you want to create, you can write classes. We didn't go to the classes still, so we will start working here. Now, coming to the case of list, what is this list doing? So list means it will store the values in a square braces. Within the square braces, you give anything it can store. There is no limit. So, and how many values also we can store. In generally, if you go to other languages, there is some problem that, beyond a limit, we cannot store the range of a value. So I told you earlier also, what is the largest integer we can store? There is no practical limit. Then memory is finite, right? Everyone's system is finite. Then what it happens? Means everyone will have the RAM system. In our system, we will have something called as RAM, ROM, so, hard disk, right? Hard disk or anything. So generally when you're working, so ROM is like, firmware. So it is something like whatever the operating system or like, the vendor who created this one, like HP or Dell or so and so, they will make their firmware. So to make the operating system. Sorry. So if you want to make any changes or whatever the code when you are running, it will run only in the RAM. This is the most important now. So every time we need to understand that RAM is the most finite value, and this is very much crucial. In everyone's system, we will have very small RAM. If someone asks what is your hard disk, they say 500 GB or 1 TB. But RAM, they will say 16 GB or like 8 GB or something. So RAM is costly. So that is what's most important. So we cannot do anything without RAM. And within the RAM also, there will be two types of things. One is a heap memory and the other one is stack memory. So once we go further, I will explain more about these two things, but bear in mind, why I'm trying to say is that this heap will be there for every program. If let's say on the system, I'm working on multiple things, say like, a Python program, say a Perl program, or like some, browser is working, say Chrome browser. Chrome browser is also one process, right? Or like something, say like some, Outlook, that is another process. For every process, there will be a heap. Heap and stack are two things. For every process, it will have two things: the data where it is stored and the data where it is referred. So I will explain in due course afterwards much more clearly. But for now, understand that everyone will have their own private heap. So within the RAM, let's say 8 GB or something, whatever the process is running, for every process, it will have a private heap. This private heap depends upon the size of the RAM. If my RAM size is like 8 GB, I will get correspondingly. If my RAM size is 32 GB, I can get much more big, right? So that's the reason. So there is no practical limit on the number of elements that you pass. Now, that's why it is called as collection, because a list can practically store any data type, any of the data type, any combinations you can place within these square braces. And tuple, coming to the tuple, same like a list, but we need to place in the square parentheses. The difference is that once you create a tuple, list, we can add elements, remove elements, and others. So that is called as a mutable object. So next you will learn this most commonly. Mutable means like you create an object, you can remove, edit, modify anytime. But whereas the tuple, same like this one, but it is immutable. Immutable means like you cannot edit it. Means inline changes cannot be done. Hope you remember, already we saw one of the immutable object called as a string. So I told we cannot do like in place changes, but whatever the changes you are doing is creating a new object, right? The same fashion. And the next one is like set. So the beauty is like set and dictionary, both will be stored in this flower braces only. But the difference is like in set, you will have comma separated values, whereas in a dictionary, you have key colon value, like that you will have. So this dictionary is also called as map or hash map in other languages. Map, hash map. So you might have heard about, in Java, it is called as hash map. In Go language, it is called as map. Or if in JavaScript, it is called as object. So like the different languages gives it different names. But this is how it works. And coming to the sets and dictionaries, these two are also mutable objects. And dictionary also, it is a mutable object. Means we can change everything except the tuple. Then, so afterwards, they added one more thing within the sets called as frozen set. So frozen set, which is like a immutable object. So at the basic, there were 4 data structures and you understood this thing. So let me add it like this one. So within this collections, I want to add explanation .txt. Okay. So now within this, if I want to work on list, first of all, if I go to the list, what is the list data type? What all things we can do? If I say list.py, let me start. As I told, like every data structure has its some rules. The same rules we need to follow and abide. So I am trying to help you and explain this. And one more point I forgot to mention is that you remember every time I used to write the shebang line, which is not mandatory. And in Python too, what happened is like the default encoding is not like UTF-8. I told UTF means what? Non-English characters can also be present. In Python 2, they created like only ASCII, means only English characters. So if you are using any non-English characters, you are supposed to write what is the encoding that you are using like this in a line. In Python 2, it is mandatory. Whenever you are using a non-English characters. But we are lucky enough in Python 3, default encoding is this one. So it is not needed. But still this line importance I'm telling. Next, coming back. So I told the basic data types. So we're like combined within this. So apart from this, there is one more data type called as iterator. I will tell you afterwards. So, but for the properties, I told that it will be stored in a square braces and we can store all the values within it. So to start with, let's say I'm creating like a empty list. I created an object called as empty list equal to square braces. So you don't give any value, just you assign it, that's it. And if you ask what is the type, if you ask, hey, what is the type of that list and the values, you will get it. If I go further, 0, 1 here and Python a so and so. Did you get the list? Fine. Similarly, and it is like empty. I told that any object which is iterable, for that we can apply the for loop. So for those things we have length. So in the initially for integer we tried, we cannot get the length. For strings we got the length. Similarly for list we will get the length. At this moment it is like empty, that's why the length will be 0. But subsequently if I add values with something, you can see that. If you go for other languages, we can have a concept called as array. Within the array, so if you go for like C++ or Java and others, there will be array. And this Python list is slightly different from that array. In fact, in Python, there is some module called as NumPy. Within that, there is something called as array. So NumPy arrays is slightly different from Python list. In NumPy array, all the values should be of same data type. Here, you can have all same data type or different data type also. Initially, I'm taking all homogeneous list. It will work perfectly. See, I gave like some values. It is telling that you have 5 elements. So if the same thing, if I give with a non-homogeneous values, means different data types. If you observe, I gave an integer, float, negative float, then like, a very big number. So string and a boolean and some expression also I gave, and expression as a string I gave. Whenever you give any expression, the expression will be calculated and the result will be applied. Did you see? Instead of the expression, the result is there. Instead of expression, the result is stored. But did you see that you can accommodate all these data types? And you see what is the length? The total number of elements is equal to 8. So that is what it happens. So, and not only this, now comes the concept of dimensionality. So generally we call it as 2-dimensional, 3-dimensional. But in reality, we know 2D, 3D means you may imagine like a graph or something, but nothing like that. Dimension means index. How you are referring to this object and getting the values. So generally, if you have this object, if you observe that you have individual elements, integer, float like that, but did you observe you have one more list within it? So that's why these are called as collections. Collections can not only store the basic data types, but can also store another data structure also. And within that, it has a tuple, if you observe. Now, for this particular thing, I'm asking, hey, what is the type of it? And what is the values? And what is the length? Generally, length means what you expect. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 were there. You expect the length to be 10. But did you see that you got length as 6 only? Why, sir, like that? Means at the base level, it will treat values like this. You know, indexes starts from 0 in Python. So 95% of the languages, it will start from 0 only. So if you see, it is starting from indexing from 0 till the length of the thing. And did you observe that this entire thing is a single list? So at the base level for this list, this is just one element. Within that, there can be values. but this is treated as one element. That's the reason you will get a length of 6. Now, sir, if I want to go to a particular value within it, say if I'm going to the third value. So the beauty of collections is that they not only store the basic data types or any data types, but they also retain the properties of them. If you see, what is the third value? Third value is 4.3. You're getting 4.3, which is a floating point value. Exactly. And similarly, if you go to the fourth value, which is an integer, you got like an integer. Means it not only stores the basic data types or any value you give, but it also retains the properties of them. Now, sir, we got like the fifth value. Hope you remember the same indexing rules of strings will apply here also. If I ask, hey, give me the sixth value, does it have a sixth value? No. If you ask a value which is not present, then it will say index error. So as we know, the same thing happens. Now let's go in detail. We understood the fifth value is very big enough. I will ask, hey, give me the type of this fifth and like give the values from the fifth. If I ask, did you notice the fifth value is like the entire list? You got entire list. Within that, you got a tuple also. So that is what is working. Now, if I go, did you observe that if you want to get this 6, then how to get? Now, the point is like we need to add one more dimension. If you observe, at the base level, this is the 0th value, first value, like that, this is fifth value. Within this list also, this is 0th value, first value, second value, like that, right? If I can add that index for you to visualize, 0th value, first value, second value, and this completely it is the third value, right? So if I ask, hey, give me these values, you can get correspondingly. So if I ask, hey, give me the, did you see what I'm doing? ML is a list of 5 of 1. So we should speak like this. Of means within the braces, like this we should say. So just 5, if I ask fifth value you are getting, within the fifth value if you want, you need to do 2 indices. Did you observe? So this is the 2-dimensional, I could say, because 2 dimensions you have applied. And within that, if you observe the third value, if you observe the third value, it is a tuple again. Means it also have further indices. If I go within it, let's say if I want to get the 9 or 10, I need to apply like of 0 or of 1, right? So that's the reason. If I want to get a value, so I will give that index. If you observe, I gave that index. Did you see what happened? 5 of 3 of 1 is 10. So in this list, how many times you have gone in deep? So how many dimensions are there means this is a 3-dimensional list. Hope now you understood what do you mean by dimension. So it's a 3-dimensional list because maximum you are using 3 dimensions to get all the values, right? So this is the concept of dimensionality. Now coming back to these rules of forward and reverse indexing. Hope you remember, I need not tell again. So whatever we have learned in the strings, the same rules work. In reality, everyone should know that there is no concept of reverse indexing. That is just for a pure convenience for us. But reverse indexing will be starting from -1 in a reverse direction. For the same things, if you start the directions, if I say -1, -2, -3, like that, and within the also -1, -2, -4, like that. So you can work. So for forward indexing, reverse indexing. So I don't want to tell so much spend time there, but just I want to tell you these things. The same rules of forward and reverse indexing will work. If I ask a ML of -5 or ML of 1, both will be the same. In the same fashion, hope you know the rules of the slicing. Indexing means like getting a value at a particular place, particular index position. If that particular index position is not present, it will throw index error. If it is present, it will give the value. That's clear. Whereas slicing means from the starting position till the last position, you get all the values. immediate value if you want, or every alternative value, that is the step, right? I told you it many times, be it in the range function or in the strings. So I don't want to touch on the slices, but this is simply to say. And one more thing I want to bring to your notice about this slice function is that in slices, the rules of the slices are the same. I just don't want to tell, but I want to bring to your notice that there is one built-in function called a slice. There were some built-in functions like this, like bool, slice, and all these things. These functions we will not use any time in reality, but it will be done in the backend. Means, so simply I'm telling because you already know. So if I say starting index, final index, and a step, if you write like this, or if you do a slice of it and write like this, both will be same. But in reality, people prefer to do like this. So instead of writing a slice function and doing. So, but if you write like this also, indirectly, it will go back to the slice function only. In fact, when you go to the iterators, I will explain there is something called as iSlice. It works in the same lines. But this is what it works. Hope you remember the assertions I told you, right? Means if both statements are not equal, it will throw an error. So if I run this statement, all the prints will print and the assertions will be evaluated and executed. Here. So Python be so and so. Did you see? So prints came and did you see assertions were done? If there is any issue, it will throw an error, right? So now we understood that if I ask 2 colon or slice of 2 comma none comma 1, both will be the same. I told in terms of the slicing, you can not give the starting or final index, or even you need not give the step also. I told there will be defaults. The default starting index is +1. Default final index is so length of the string. So and also the rules will be the same. So hope you remember the negative values colon -1. When the starting and final index were not given and the step is negative, then it will be doing the reverse of the string, right? Same like here, reverse of that list will happen. All the iterators means on whichever the objects you can apply for loop, the rules will be the same. So be it like slicing, all these things. Now going further. So coming to the case of mutability, most of the people will get this confusion about it. So let me tell, say, so B1, mutability. I am telling that list is a mutable. So if you see any interview, the first question they will ask is what is the difference between list and a tuple? So we say it is a mutable object. Mutable means what? So if you to understand, so I have defined one variable and I'm asking, hey, what is the address location and all these things. If I ask, hey, what is the value, type and address location, it will give some address location, right? So clear and Python B1 so and so. It is saying that int 1, 2, 3, 4, it is an integer, it is in this location. And I will again give one more value, same like that, but I will give something else. If you observe right now, if I run every time, the address locations will change. But one thing you observe, for the same variable, I give one value. For the same variable, I give one more value. Means it is overwriting, right? When it is overwriting, did you see that address location is not same? Means it created a new object and wrote it. That is fine. That is not called as a mutable. So if you go for the example of second example, say I'm going for the strings. I have a name called as Rajshekhar. If I ask 0 through 2 to 3, I will get like Raj. This is clear till now. This Raj, if I want to convert that to Tej, so in this word, so can I do like this? That hey, as I referred 0 to 3 as Raj, can you overwrite it to Tej? If it supports, it is a mutable object. Hope you remember in strings, I told something called as a byte array string, right? Byte array string is a list of the positions only, in fact. So that is a mutable string. Whereas an ordinary string, it is an immutable. It says type error. You cannot do like a in-place changes. So the point is like, if you do like this, it will do like a in-place changes. So whereas, sir, what if I say name is equal to Tej Shekhar? Hope I can do like this, right? I cannot change directly like that, but I can do like this. Now, what is the difference between this and this means? Here it will make in-place changes. So that's why strings are not supporting that. Whereas this is like simple overwriting. So to understand more, if you ask the data type of it, so ID or address location of the value before and after, you will understand. So address is changing, right? Every time. But after that, if you ask, hey, what is the name? So the name was overwritten. You can see it becomes Tej Shekhar, but the address locations are not same. Here also address locations are not same. Now, if I go for like the multi-dimensional list, then you can better understand. So till now, I showed about the concept of multi-dimensionality and all these things. If you want to refer to a particular value and a type and all, you will get it. So you got one address location. See, like every time the address location changes, but it doesn't matter. So if I want to get a particular value within it, say the third value is 4.3. If I ask also, I'll get 4.3. Now, can I change that to something else? ML of 3 is equal to 3.4. You see, in a string, you are unable to do. So not in a single character or a string, you cannot modify. But here, you are able to modify. If you see, it is not throwing any error. So let me make a print after that so that we will understand. I'm asking here, what is the new list and what is the new address location? If you observe, so in this particular first case, what is the address location? Fine. In the second location, what is the address location? Both are exactly same, right? 2. And if you see in the ML list, so initially it is 4.3 and you changed it to 3.4. And did you see that 3.4 happened? So now 2 points observed. The new values have the new changes. At the same time, address location is not changed. So this concept is called as mutability. And not only this, you in just not like a indexing and changing, you can even change the values also by doing a slicing. I took 3 values and I want to replace with another 3 values. Or if I took 3 values, I want to replace with 4 values. It doesn't matter, it will work. So if you ask, hey, what is the address, new result and address, you will see the new result is also the same. In the first one, the address is same. Second one also the same thing. And in the third one also the same thing as the address. Now, did you see? No, whatever the changes you make, the changes will happen on the same object. So without changing, this is called as a mutability, which is supported in a list, which is not supported in other data types till now. Hope it's clear for everyone what is mutability means. Any object that supports in-place changes. So that is called as a mutability. Next concept is about the attributes of this list. What all things we can do with this list? Attributes are like a usage, right? As I told you. For any object, if I take, say, I took like some list of values and I'm asking the data type and the DIR. So I told, if you want to know something, what data type it is belonging to, type, and what are the usages of it, that's where we need to go for the attributes. Within the attributes, you can see a good number of attributes. Hope you remember I told earlier that we will not discuss things which have underscores on either side because they were alternatively implemented. So even if you say, still there were a good number of attributes which we can touch base. So within the list, we can do a lot of things. So I am telling that we will not touch the things which have underscores on either side. The reason being, for them, they have alternative implementation. Let's take the example of the length. Length can be calculated using length built-in function or underscore length attribute. So in fact, both will give the same result. So that is what assert means. And similarly, if I want to calculate the, convert this list to a string, I can convert using this string built-in function or underscore underscore str. In fact, both will give the same result. So in the same fashion, you can do REPR also. That also works in the same way. And similarly, if you want to work on like a string repetition operation, so if you ask the answer, you will get the same things, of course. I'm not just printing, you can just see. And in the same lines, if I ask, there is something called a string repetition operation. I think like in recent languages, whatever I see, Python is something very unique that you can multiply an integer with a list. We can multiply integer with a string like that. So if I do like in a interactive mode also, you can see the same. If I say IPython, I can work on interactive mode within the console, right? If I say like, so the same thing. Numbers equal to 1, 2, 3. For numbers, I can multiply by 2, you got it. So if I multiply by 3, you got it. Did you see the same thing is repeating? So 1, 2, 3, 1, 2, 3, 1, 2, 3. But you cannot multiply by 3.4 or 3.3. So this is possible only with integers. So the point is like either you can do like that or you can do underscore underscore mul of 3. So this and this operation both were same. In the same fashion, after doing the things, if you still ask, hey, what is the original value? It will not be changed. Means these are not making in place changes, but these attributes are working. I told for this either directly or like indirectly, either way you can use. But if you want in place changes, so you can do like a IMUL. IMUL is like, numbers multiply equal to the 3. So this is same like this one. Multiply is different from multiply equal to, right? So this is multiply. But multiply equal to means what? This is a compound operation where you assign the value result also. So that is the difference. But here you can observe that, so what are the changes you make? It will be supported. So when you are doing like a overwriting, the value will be changed, right? When you are reassigning. Next, similar things. What else it supports is next, apart from this list repetition operation, the next thing that you will see is about list concatenation operation. This is another interesting thing. So you have a list, numbers, fine. So if you want to add like, 2 or a 1, we can add? No. Python is a strictly typed language. Strictly typed means only objects of same types can be added. Added in the sense like if I do like 1 plus 2, it makes sense to say that add means addition. If I say 1.2 plus 3.4, it also makes sense of adding. But if I told for a numbers, which is a list. So for a list, if you want to add, the only thing is you can add one more list only. If I don't give any values also, fine, it will add. If I give some values also, fine. So here addition means like concatenation. So that's what plus is the only operator which supports multiple operations in different situations. So this is called as operator overloading. So Python supports operator overloading. So, but like this. So when you give two lists, it acts as a list concatenation operator. When you give like two tuples, so tuple concatenation. So as I told, like both should be of same type. If I add like a tuple, I cannot add. So this is what you need to understand. So in terms of addition, you can use plus operator or underscore underscore add. But these will not change the original object. If I, after doing these changes also, if I ask, hey, what is numbers, it will give the same value. But if you want your changes to be applied to the in place, you can use like a IAD. I told you, right? IAD is same like numbers plus equal to. It's same like numbers plus equal to. Compound operation. Similarly, not only this, you can also do like membership check. Membership check is the next operator which supported in the list. So numbers is like a big thing. Within the numbers, if you want to check whether some value is present or not, we can check like, so 3 in numbers, or like, so if you want to check for a string, say A in a list of values. So you have like A, B, you have C. You are checking the particular character is present in or not. For that, you can use in operator or underscore underscore contains. Both will work in the same way. So like that, there were multiple things which have underscores. That's why we don't touch it. And there is one more thing. So about the underscores is about underscore underscore size and get size of underscore. Sorry, get size of. In Python, there are two ways to get the size of an object using the underscore underscore size. If you see this, it is very interesting. If I tell, say, I want to get numbers dot underscore underscore size, it says something. But if I import sys module and if I say sys dot get size of same numbers, did you observe that sys dot get size of is giving slightly more memory? Does it mean that there are two different values? No. So sys size of will give the Python object size, whereas get size of will give when converting to the base language. Means there is one more interesting point I will tell. In Python, there are 3 flavors of Python called as means Python, if you know, is an interpreter based language. It cannot work on the machine. If you need to convert anything to the machine language, you need something called as compiler. And Python don't have a compiler. So Python code, whatever you are writing, will be converting to like a C language. And that C language can convert to the SM compiler, and that will convert to the machine level language. So machine level language. So this is like the compiler. So Python is converting to C language. That is called as like a C Python. Similarly, there are other implementation called as from Python to Java, it will convert, and Java has a compiler. Similarly, .NET it will convert. Like that, there were 3 flavors. But 90% of the time, most of the people will work with C Python. So now the point is when they are converting, they will have the C header, right? So object size plus C header size. That is the total thing. And lastly, if you want to get the documentation for any object, so not just list, you can use underscore underscore doc or help. Both ways you will get the things. So these are the 2 ways you can get it. So next thing that you will see is about, so the remaining string operations.